You're good.
Alright, so this is the real version of the theoretical circuit. We have our power supply here, and the power's coming out of this wire, coming up through to our switch. Our switch has two configurations, A and B. And while the circle rotates, when it gets to this bump, did you hear that click? It changed the configuration. And then circle turns halfway around, and at the other end, it changes it to the other configuration. And so let's imagine we're in configuration A. Power, it's going to complete a circuit through this wire here, and this wire goes to the top capacitor plate in our circuit. And this is a capacitor, even though it just looks like a big circle. And so we're gonna lift up this plate, and those little purple pieces of plastic are 0.19 millimeter thin. And the dielectric between these two plates is the air. So I'm gonna let this plate back down. And now let's look at the bottom of our capacitor plate. Our bottom capacitor plate, excuse me. And it goes back to the power supply and is also connected with our voltmeter, which goes back to complete a circuit with the power from the power supply. So now let's imagine that the circuit has gone to configuration B. Now the circuit is from this wire, from the top capacitor plate, to this wire here, which runs through our multimeter, which is measuring microamps. And then it runs back through to the other side of the capacitor. And those are all the components of the circuit. But we need to measure something else. So we have an oscilloscope here, and we are going to connect one end of it to the bottom capacitor plate. And then we're going to connect the other end of it using an alligator clip to the top capacitor plate.
And that's measuring frequency in hertz when we turn on the oscilloscope.